It is my pleasure to introduce Josh McKenty. He is the co-founder of OpenStack, which he did while he was at NASA. He is currently the CTO of Cloud Foundry at Pivotal, and I will let him take over. Please give him a warm welcome.
Thank you very much. I have no idea why all of you came out today. Honestly, it's Friday afternoon. So I'm going to make this as interactive as possible because I think it'll be more interesting if I'm actually answering your questions rather than just sort of mouthing off. Am I on, Greg? Is that good? Okay. The first one of the things I ever did sort of in recent history was at CERN, right after we started working on OpenStack, long before it was called OpenStack, and before we actually were even allowed to tell anyone that we were partnering with Rackspace. And it was an extremely awkward talk for me because I worked at NASA and I was going to this other science institution, and so they sort of naively assumed that I was a scientist, which I am not. I'm not a computer scientist. I'm not even really qualified to be an engineer. And so I spent most of the talk sort of backpedaling of like, don't treat this like science, it's just something we happen to be doing. I'm basically an open source guy. And then, so I felt like a fraud. And then I spent the next 5 years mostly talking to business people about like how cloud was good for companies and businesses. And I wasn't at the time a business person, so I also felt like a fraud. And now I'm back in the one thing that I used to be good at, which is talking to developers about writing software, except I haven't written any software in 5 years. So I'm back to feeling like a fraud, basically, of like, I know you guys write software. I used to do that too, but I've spent the last 5 years talking to business people and talking to scientists, so I have no idea if any of this is going to make any sense. But it'll be fun anyway. There's a lot of history with tequila and the state of Texas in OpenStack. And so I usually preface this by saying I'm going to talk about OpenStack, and I'll talk about Cloud Foundry, and I'll talk about mistakes. But mostly the history of software and of open source is about people making mistakes. Because humans are not good at making decisions. And I was just joking at like the way you guys have filled this auditorium. It's sort of a great demonstration of the fact that logical people do not make logical decisions. Like, I will sit at the end of the row on either side so nobody can get to the middle. Not on purpose, but just because that was, the context that we had. We operate in the context that we have, which means that hopefully we make progress by making a series of smaller mistakes and eventually converging on something that sucks less, if we're lucky. The only advantage of using technology in this process is that it allows you to make mistakes at an incredibly high rate. And so it speeds up the whole process. And I've been talking a lot recently about the fact that in IT especially, I found in the last 2 or 3 years, people are behaving as though we are in some weird period of time where everything's going really fast and things are changing really fast, but that in the future things are going to slow down and go back to normal. There is no evidence to suggest that we will ever go back to normal. Things are going to continue to go faster and faster and get stranger and stranger. So we just need to get used to the new normal, which is about going as fast as you can and knowing that it's too slow. Therefore, lots and lots of mistakes. All right, I did want to sort of give you a little bit of context so that you know what kind of questions to ask me, because this will be mostly questions. As my introducer, Michelle, Lindsay, one of you, Michelle, see, I got it right the first time. I was one of the co-founders of OpenStack. I've spent most of the last 5 years working on OpenStack in one way or the other. Most of that time I was on the OpenStack board. I stepped down in October. I was the last of the founding board members to leave. So if you want to talk about open source governance, I've done an uncomfortable amount of that. I also started a company selling OpenStack called Piston, which I left in October as well after about 4 years to get back closer to application development where I would feel like less of a fraud. When I was hired at NASA, I was hired to build a PaaS. And we didn't have an infrastructure as a service layer at all that would work, and we spent the first 6 months trying to do it with what we had, the next year trying to do it with other tools available, and eventually we gave up on those two, built OpenStack instead, which was supposed to be a very short project. When we scoped it, we're like, we can do this in 3 weeks. How hard can it be? It's basically just some scripts around things that already exist. We're not writing a hypervisor. We're not writing distributed storage. We're just going to automate and orchestrate those things. Turns out that's actually a pretty hard problem. So 5 years later, I'm back on Cloud Foundry, which is kind of what I was trying to do in the first place. And so I have some experience with that. I've also used it a bit in the last few years with customers who are doing both. And years ago, I was a tech lead for the Netscape browser. So I just referenced that as yet another crazy open source project worth talking about. I'm going to try and keep this pretty technical because I heard you guys were smart, which means you're way smarter than me. And I'm going to do a little live demo because really I want to talk about the experience of what it is like in this imaginary future where you actually get to use Cloud Foundry plus OpenStack together. And I want to keep this real by saying, look, this is all about making mistakes. This is not every year somebody shows up and says, magically, if you do what I'm telling you to do, the future will be all rainbows and unicorns, which is never true. But it is worth trying to get to that future anyway, because maybe it's not rainbows and unicorns, but maybe you have an umbrella when it's raining. I usually don't make any sense. All right, so this is why the Fortune 500 love open source software. This is to put things in context, because I'm an open source guy, but I am not one of those religious open source should be free as in beer. I'm an open source should be free as in speech and love. We used to have a slogan, OpenStack is free as in speech, love, and beer, but nobody got it, so we stopped. Most people, 99.999% of people that use open source software will never submit a patch. Firefox, anybody? Linux for most people. OpenStack for increasingly everybody. And Cloud Foundry. So the idea that open source is about being able to change it is mostly not true. It's potentially true, and there are people like yourselves for whom it is deeply true, but most people not true. And it used to be that people thought that open source meant it was going to be cheap or maybe free, and that was why it was awesome. But the reality is, most long-term sustainable open source software has people that make money off of it. Because 99.99% of the people that work on open source software are paid to do that. I like to eat, as do most people. Getting paid helps support my eating habit. Especially in Kansas City where you guys have amazing barbecue. So why do we like open source? One is, and this took me a long time to figure out, I've been doing Agile for years, and I've been in open source for years before I realized that doing open source forces you to do Agile. And if you think about it, if you go and try and commit a patch to, I don't know, WordPress or Firefox, if it's a 6,000-line diff, nobody will review it. You could show up in person with whiskey, and they are still going to ignore your patch. I have tried. If it's a 50-line patch with good docs and some test coverage, you get on IRC, and you're like, here's what I'm kind of trying to do, and I'm going to show you a patch tomorrow. Does this seem okay? This is my approach. Sure. You can do that every single day for 2 weeks, and the next time a release comes out, you're going to have 50 patches in that release. That is Agile development. And when you have a large community of folks planning a short distance ahead by talking about exactly what they're going to do, supporting it with incremental improvement and good test coverage, you just reinvented Agile. So that's why everyone says, well, all of the innovation's happening in open source, and everybody's IT infrastructure is going increasingly open source, whether it's all the way from the bare metal up or just a couple of those layers. When people say, community has the innovation, this is why. I'm going to talk a bit about culture, but mostly I'm going to try and skip straight to a demo. So I'll say one other thing about culture, which is folks that are in the habit of being transparent with the outside world, which you have to be in order to do open source, tend to have good communication inside their organization as well. If you're in the habit of talking about what you're doing and why you're doing it and your logic, that will be your culture. Large companies that are in the habit of being very secretive with the rest of the world tend to be very secretive internally as well. So it's hard for them to innovate even inside their own walls. So these open source habits drift into everything else that those companies and organizations do, even when they're not writing open source. They tend to do it as if they are. Same communication styles apply. I think that's a really interesting side effect. The last thing is, when you go to buy software, it's really nice to have more than one vendor to choose from. Not because they're necessarily selling you something different. They can be selling you exactly the same product, but because it keeps them honest, keeps the prices reasonable, and it keeps the SLAs reasonable. So this is all business stuff. You can tell I'm used to talking to business people in suits, right? But it's worth keeping in mind when you look at open source and say, well, why did they do it that way, and why is it Apache licensed, and what's the community about? This is the backdrop of what I see really happening. Bear in mind, OpenStack. How many of you have heard of OpenStack? Okay, that's cool. When I first started doing these talks, nobody had ever heard of it. There's 20,000 members of the foundation right now. We're in the middle of a vote this week. If you're a member, please vote. The election's almost closed. We are trying to get a large enough percentage of our community to vote on changing the bylaws, so we don't need a large enough percentage of the community to change the bylaws. We never thought it would be this big. Like, we have process problems just with the size of the community. And it really becomes a really good litmus test to say, hey, things that are true in OpenStack are probably true in general right now about open source. And so it's easy to steal lessons from. Culture, everyone likes to feel like they fit in. People like to join communities that look like they're full of cool kids. And they copy the behaviors of the folks who were there first, which means the culture of a community tends to become more and more the culture of the same community, reinforces. So OpenStack has always been a culture of unit test coverage, rough consensus and working code, and drinking bourbon. I don't need to emphasize any of that. Okay, the reason Agile matters is because the world is moving too fast, and it's not just that software is moving too fast, the entire world is moving faster. S&P 500 is 40% different in the last decade than the decade before. It'll be 75% different this coming decade. Entire industries are disappearing. How many of you ever taken an Uber? Okay, Kansas City just got Uber, so I guess not super common. But, it's 100% of everybody in San Francisco or Seattle or London or Paris. It's crazy. OpenStack was built in the same style of agile development, doing continuous delivery, right? And this was our blog post when we first launched Nova, which was the first half of OpenStack. And we wrote V1 in 17 days, which, data center infrastructure software. It is hard. It took us a long time to get it to a point where millions of people are relying on it. But being able to go fast really, really matters. And increasingly it matters not just because it's more fun to write code if you can get quick feedback, but some projects I don't think could ever even exist if the tools couldn't keep up. People drift off, they'll go work somewhere else, they'll go to Google. Speed matters. Okay, I'm going to talk a couple of math terms just to put the rest of this in context as well. And also because I like to feel like I threw some math down on you. There were a bunch of people I talked to this morning. We talked about networking and why is the network so important and why should application development still have to even think about the network when we really have been able to stop thinking about CPUs and stop thinking about storage. I harp on networking a lot. So I just want a little snapshot. This is also a way of thinking about the rate of change in the world, right? We're producing enormous amounts of data. Every time we produce more data, we come up with new things we want to do with it, which means we process that data in new ways, and we generate more data ad nauseum. If you have bacteria in a jar, and you put the jar out on the table, you can't see the bacteria, but maybe they're breeding in there. Day 1, you can't see anything. Day 2, you can't see anything. Day 3, you can't see anything. Day 4, the entire room is full of bacteria. And the amount of time between when you could have seen them in the jar and when the room is full, it's like 14 seconds. People have a hard time reasoning about exponential growth, right? The gap is so large. I'm going to caveat that in a second, but let me talk about networks. Everyone's heard of Moore's Law. You can quote this later. You go back from this tech talk and go, what did I learn? Well, I learned about the mobility gap. It's not useful. It's not related to my job, but I can quote it. Moore's Law CPUs get faster, exponential, it's awesome. Kreider's law, storage gets cheaper and more dense, exponential, it's awesome. Nielsen's law, networking gets faster, not very awesome, close to linear. Less awesome, which means the gap between being able to produce data, store data, and move it around is getting worse and worse and worse at an exponential rate. So we're only a couple of years into people talking about big data, talking about MapReduce as this magical thing, and like Hadoop is super cool. Hadoop is just a solution to the mobility gap. Move the processing algorithm to the data because moving the data around is too expensive. And when it first came out, people were like, that's vaguely cool. Why would that be interesting? A few years in, they're like, oh my God, everything has to go into Hadoop quickly. We're about 6 months before people realize Hadoop is not a general purpose solution, that graph databases solve a different class of problem, that you need time series and geospatial indexing as well. Like, a lot of other problems still in that space. But the point was the gap between when we had a solution for the problem, when people realized the solution was potentially useful, and when it was a crushing problem for entire industries, was actually really short. When you look at the last 30 years of managing data, where it was like, I can spend a couple of years thinking about different sand vendors, nothing's on fire. When you think about applications, and I'm about to talk about OpenStack and Cloud Foundry for honest. When you think about applications, and everyone says, oh, we got hundreds of apps in the building, we've got all these problems with our legacy apps, and what do we do, which ones we do move, and which ones we not move, and how do we migrate, and what's the story here? By the end of the decade, 90% of the applications you are dealing with are ones you haven't written yet. So the problem of dealing with tomorrow's applications is so much bigger than the problem of dealing with yesterday's applications that you are the most important people in the company. How you decide to write the applications you're working on today and tomorrow and the day after will dominate everything that happens in IT at Cerner, and therefore probably at Cerner, for decades to come. So I generally tell people, they're like, well, we're going to sort out this legacy problem first, and we'll get around to doing these next-gen app dev things. I was like, you got the order wrong. Those legacy problems feel huge because they're 100% of your problem right now, but by the end of the decade, they'll be 10% of your problem even if they don't shrink, because your new problems are going to get so big. All right. The other one is Conway's Law, and I just want to very briefly touch on this before I do demos. Have you heard of this? How many of you have heard of Conway's Law? A couple of you? Okay. If you have a team of 4 people and they write a compiler, they will write a 4-pass compiler. Sorry, 4 groups. They'll write a 4-pass compiler. This is always true. The number of teams you have will break down into the number of components you have in your architecture. You won't do it on purpose. You just can't help it. My favorite example of this is this was a photo of the moon, I believe. Could have been Mars. Now I can't remember. It's been too long since I gave this talk. This is the only photo we got before we hit the surface of that planet at like many hundreds of miles an hour. This is because NASA had 2 different groups building 2 different parts of the spacecraft, one of which was working in metric and one of which was working in imperial. So this is a Conway's Law failure, whatever, $500 million mistake. But you can use Conway's Law for good. You sort of do it, and I mentioned culture before, and I had a picture of a bunch of cool kids. Conway's Law is this idea that your code will look like your community. There's cultural cohesion, which basically says your community will look like the culture of the people involved in it, because everyone who gets involved is going to copy what the people who are already there are doing, because you want to feel like you fit in. If everybody already writes tests, you'll write tests, because that's how everyone does it. And so hacking Conway's Law, you hear about this new idea of microservices, right? They say we're trying to build more and more complicated applications, and we need more and more people working on them, but if we do it as a one big team, it doesn't work. And so we realized if we break them down into a bunch of components, and we make the components talk to each other, that works out, because one team per component. What you do is you really have to get the relationship between the components right. Communication, contract. Other people are smarter than I am about microservices, right? Also, when you think about infrastructure and you think about hacking Conway's Law for how you manage infrastructure and the relationship between your networking group and your developer group and your ops group and your QA group, if you have one, and the product manager and everyone else, if you have to file trouble tickets to get VMs, that's the bad kind of Conway's Law. I mean, NASA, when I first got there, it took 6 months to get a VM, which they thought was really good because it took a year to get a physical server. still talk to very, very large companies who are like, we can spin up a VM in an hour. Why do we need cloud? We worked for 5 years to get VMs in an hour. I was like, well, if I can't get a VM in less than 10 seconds, I'm going to use AWS. Post-hoc adjustment, you can fix things as you go. There are certain things you got to get right. There are other things you can adjust as you go. Figuring out which side these different bits fit in is really important. All right, avert the danger which has not yet come. Re-emphasizing, you've got 90% of your problem that you haven't created yet. You got to get in front of that. Okay, those were a bunch of words. Cloud Foundry is this thing. How many of you heard of Cloud Foundry? How many of you used it? Okay, good. This will be a good demo. There are lots of people involved. You can use it for any language and any framework. It uses both VMs and containers. So it's not Docker or Kubernetes. It's not an alternative to OpenStack. And it deals both with applications in terms of stateless running processes, data services that store state like a database or a queue service. There are a whole bunch of people involved, and a lot of those people are also involved in OpenStack. So even though they're totally different languages, totally different communities, came out of different efforts, there's an increasing amount of overlap, and so I'm spending a lot of my time talking to people who like OpenStack, saying, yeah, Cloud Foundry, very similar community. Said language and service and IaaS agnostic means you can run Cloud Foundry on top of Amazon, on top of OpenStack, on top of vSphere, on top of Google Cloud, on top of Azure. Some of those are community supported, some of those are commercially supported. Lots of different data services available from lots of different people. Lots of languages. It uses, if any of you are familiar with Heroku, uses build packs. So you can use the Heroku build packs. There are also Cloud Foundry native build packs. You can build your own. I have built a few of them. I'm going to do some demos. This will be because most of you have never tried Cloud Foundry. And I'm doing that really stupid thing where I'm doing a live demo that I didn't really prep or stage because that's super fun, right? So, sorry. I'm going to fumble about for a second. While I'm doing this, which will be sort of embarrassing, start thinking of questions because, as I think Michelle pointed out, we're really keen to have people ask interesting questions, and if you do so, we'll be really nice to you. Okay. Now, in the spirit of IaaS and PaaS everywhere these days, there are both CLI tools and web tools, and they use the same APIs, which means you could write a new CLI if you wanted to, right? I'm actually going to mirror displays rather than have two windows because it's making me dizzy. And then I have to get the right window up. Okay. This is what we would call, okay, web interface for Cloud Foundry. Hosted version of Cloud Foundry called Pivotal Web Services, which is run by Pivotal on top of AWS. Lots of people use this for dev and test. A few people use it for production apps. It's essentially the same code as what you would run on your own hardware. And there's some basic ideas of orgs and spaces. I don't want to drill through every feature because you guys are devs. You can go try this later. 30-day free trial. Just go sign up. But when you're pushing an app, which is your essential unit of measure, you target an organization and a space. And so as a developer, if you're subbed out to different business units inside your organization, they might have different orgs. And you have dev and test and staging and prod as spaces in there. So when you push an app, you can be deliberate about where's it going. One of the nice things CF does is when you're using, let's say, a database, if you need a connection to a database, you don't hard code the connection string into code, right? We all know that. You don't put it in a YAML file even or load it in. It is managed by the platform and pushed into the application at runtime as an environment variable. So you expect it's in a certain environment variable. You grab that in your code, and you connect to that database. So I wanted to show an app, a couple apps, 2 different languages, and to cheat, because I wasn't sure if the Wi-Fi was going to work, and I wasn't sure if there would be ports blocked, which turns out there are, I use a continuous deployment tool called Worker. So if you're used to Jenkins, think of this as like hosted Jenkins for hipsters, right? I don't want to go into all of what Worker does, but basically you give it a build script and a deploy script as a set of steps or commands in a YAML file. and it will watch GitHub or any Git repo, and when you push code, it will go and run those steps for the build process, expect some output from your tests, and if your tests pass according to your own criteria, then it will run the deploy steps for you. You can deploy different targets and so on and so forth. So I have a couple of apps here. I have this one called AfterStack, which is in Go. The joke being that at all of the OpenStack summits, there's always after parties, and nobody knows where the after party is going to be, and then there's people talking about it on Twitter, and then we're trying to coordinate like 4,000 people to show up at some pub in London. So we decided we needed a web app with some API. We haven't actually built it yet, but we bought the domain name when we were drunk. So I started sticking demo Go code on it. Yep. Better, sort of? Okay. This is a super, super tiny Go app with Martini. How you guys, if you've seen Go, you've probably seen this app. Simplest little web service. And it binds to the /hello and gives you a little string. So I've got this code, and I've got it in the editor, and now I have a command line prompt for AfterStack. And I'm going to target the dev space, which I think I have to type as development. Yeah. Sorry. Okay, and I can say what apps are running there already. Okay, well, I've got a few of them, but one of them is not AfterStack. Oh, right, I forgot I put that in staging. Don't ask me why. Seemed like a good idea at the time. All right, and CF really does everything for you. It's intended to be this all-consuming experience where if you do a CF push, it's going to set up DNS. It's going to set up log aggregation. It's going to, oh, of course, it's already in. Well, let's just generate a random route then. I'm running a copy of it already, but it doesn't know that I'm running the same one because I changed the app in between. That's what happens when you do too many demos. Unspasmodicinjuriousafterstack.com. Maybe I should make this bigger so that's funny to you as well as me. So you get DNS, you get load balancing. So when you scale out your app, you say, give me more instances of this thing. It will load balance across all of them. You get, as I mentioned, environment variable management, so it connects to your data sources. Your DevOps teams can create more data sources or set up brokers for data sources you already have. So it's really easy to get that same feeling of like there's environment variables that tell me how to connect to whatever the data source is, whether it's Oracle DB or Informix or DB2, or whether it's MySQL that's in just OpenStack or managed by CF for you. And when you take that app and you push from dev to test to staging to prod, it always connects you to the right copy of the database. So you don't accidentally bind from dev into the prod database and then flush the tables. Somebody's nodding. Those of us that are old enough have seen all of these mistakes made. Remember I talked about mistakes? Most of these things are built around mistakes that folks have experienced in the past. Okay, so it's running. There's this URL that was created for it. So let's just see if magically, there we go. Okay, this is we'll go to this hello cerner. So I push an app, it's running, it's boring. Let's scale to 5. Oh, come on, I have to tell what app, sorry. Oh, now I need the name of the app that I just created. Go CF, yeah, that's what I thought. I can ignore it. It's going to go and launch a bunch more containers. So these are using containers on top of VMs, and it's going to copy the slug, the sort of built-up container image. Now, I didn't make my own container image. I didn't use a Docker container image. We do support, well, new version of CF, we do support Docker images. So if you have a different way of building your container image using, Chef or Jenkins or any kind of build process, and you want to just connect that to CF to manage it, that'll work. I kind of like the way container images are built up, and the reason is because of build packs. I mentioned you can use a Heroku build pack. If we go back and look at the manifest file of this app, I want you to know there's nothing magic under the hood here. This is the manifest file. The name of the app, the amount of memory, the amount of instances, domain, the path of the app to push, and the build pack to use. It's a GitHub URL. I have another app handy just to show you being honest here. If I look at the manifest for this one, it's a build pack I built myself. I actually built a Python one that has NumPy and SciPy support, so I was doing some numerical analysis stuff. You'll see this service is commented out here, but if I want it to bind to a database by default, I can say this is the service I expect to have running, this is the connection I want it to make. Usually, I'm fond of creating services from the command line. So it'll tell me what services are available. Oh, I don't have any running. So there's Marketplace. Redis Cloud, Mongo, Memcache, Postgres, blah, whatever. It's like Heroku, right? The difference is you can run all these on your own data center as well as connecting to other public services. I guess the one other thing that would be worth pointing out here, and it's a little hard to do with this app, there are lots of other things that could do roughly what I just showed, right? This is what I call a day one demo. So day one, I wrote an app, I push an app, woohoo! Day two, I have an upgrade to that app. So, and I'm a little short on time, so I'm not going to demo all of it, but if you want to see it later, I will show it to you later. I can do a blue-green deploy of an upgrade. I can do a blue-green deploy that includes a schema migration. Well, it's a little tricky. I can look at logs. In fact, I can show you logs really easy. CF logs, go CF. This will tail the logs out of the app in real time. So if I go back and I load this endpoint a couple times, oh, come on, just because there we are. And I have milliseconds of response time on each request. Somewhat helpful if you're trying to debug variable performance problems. The operations experience for CF is almost as good. And you know, a lot of people talk about DevOps, and in some organizations that means good things, and in some organizations it means bad things, which is like the devs are now responsible for everything in production forever, including security patching of the OS. Which means if Heartbleed comes around again, it's like every single one of you guys get up in the middle of the night, go patch the OS in every app that you ever touched and go home again. So there's some of these separations built in of like the OS base image is managed by ops people. The build packs can be managed by yourself if you want to bring your own, or by a DevOps team or some folks inside Cerner who build packs for you if you want to use those. There's a lot of operations tooling in this platform, which is kind of those day two problems that you don't necessarily want to own. Troubleshooting, and the log aggregation is, by the way, all of those different app instances, all the containers running your app that are load balanced, the logs all come to one place. So you don't have to go and be like, oh, I got to figure out which app instance is dealing with that request so I can see the logs for that app instance. I have troubleshooted in the old world for years, and I don't like doing it that way. I'm roughly out of time, and I would really like to answer questions because there's a happy surprise for you if I answer some questions. So why don't we take questions now, and then if there are things that I didn't touch on, I'll drill back in. That sound okay? People are nodding. You guys are all, it's 4:30 on a Friday. Yeah, wait for the mic.
So how does Cloud Foundry compare to other platform as a service websites like DigitalOcean, for example?
So I talked a lot at the beginning about open source and why people like open source. And the main difference between public PaaS, Heroku, DigitalOcean, Azure in the old days, Google Compute Engine, or Container Engine sort of, is that you can't run it in-house. And if you can run it in-house, you can run it only on your development environment as I have a dev environment that sort of looks like this real container thing, but there's no middle ground where you could run prod yourself. So Cloud Foundry is both open source and commercially supported open source, which means there are lots of people running their own Cloud Foundry environments. That is the biggest difference from a philosophical standpoint. From a feature and functionality standpoint, honestly, there are things that some PaaSes have that CF doesn't. Most of those we're working on, like .NET support. .NET support is hard because you have to like Windows. We're working on it. We're working on finding people that like Windows and hiring them. That was a somewhat mean joke. We actually do have beta.NET support now. So there are other features that CF has that other PaaSes don't. I think the metrics piece is certainly one of them that we're the most excited about. And also because increasingly we can give metrics between the app and the data services as well. So like you can see this was a slow request and it was slow because the database response took 2,000 milliseconds and your app only took 200 milliseconds or whatever it is. It's a lot of extra work to go do that tooling on every app yourself. And so having it in the platform makes it easier, I think. I mean, it's a flavor of App Dynamics or New Relic or something. Yeah. Joe.
Within Cloud Foundry, on OpenStack, so today the guidelines are to run Cloud Foundry in a as a single project within OpenStack. Is there any future where Cloud Foundry will be split and you'll see the Cloud Foundry tenants as more OpenStack tenants or OpenStack projects?
It's a really good question. There are a number of OpenStack projects that we're starting to collaborate with, the first one being Congress around policy support. Keystone is the second one in that list. And so Keystone is the authentication and authorization component in OpenStack. It's a bit tricky. So the thing that open source communities have to do is solve the 80% case that most people want. And infrastructure is always hard because people have long-term cultural prejudices around how it's run. Certainly when you look at tenants and roles, every industry has very strict guidelines that don't look like each other. So there are people who have done large-scale multi-data center, multi-OpenStack environment deployments of CF today. And there is nothing inside Cloud Foundry that says you would have to target just a single tenant, but it is certainly a lot easier to wire it up that way, and that's the way it's commercially supported by Pivotal. And I think the reason is because security groups and security groups in OpenStack and application security groups in Cloud Foundry are just as easy to do inside one tenant as to use tenants for that separation. Even in fact with Neutron, folks are saying, well, I want every org or space to have a separate virtual network. We've seen people do that, again, inside a single tenant using the appropriate SDN controllers. So it's something that gets kicked around, and I think from the Cloud Foundry Foundation standpoint, Cloud Foundry community standpoint, lots of people are willing to work on that problem as soon as we have good consensus on what the solution should look like. What we're cautious of, and this is one of those cultural differences between CF and OpenStack, which I consider to be one of the mistakes we made with OpenStack, is we said, hey, if you want to contribute, awesome, come bring ideas and we'll put them into the ecosystem. What that meant was over time, there's 65 projects inside OpenStack, only 8 of which are in core. Nobody can figure out what's going on. And we're very cautious in the Cloud Foundry community to have the reverse experience, which is there is one thing that's called Cloud Foundry, and everybody understands what it is, and we are therefore a little bit slower as a community to say, hey, let's go down this interesting path. And we also don't want to have 50 different options at every tier of like, oh, there's 8 different ways you can do this and 8 different ways you can do that. We're trying to keep a lot more focus in the community. So I think the answer is yes, if we can figure it out as a community that we have good consensus, but so far we haven't been able to find that. Oh, we got another one down here. You guys just want to see what prize you get. That's okay too.
So you spoke to DevOps is not dev does everything in prod. That sounds great. How does Cloud Foundry help me have team own? So you showed applications and services, and what I think I'm gleaning is that those are separate things that I can wire together. Can those be easily owned by separate teams?
Yes.
Do I need every person that deploys something on Cloud Foundry to know everything about Cloud Foundry?
No.
About all of its dependencies? Can you kind of
Most people who use Cloud Foundry will learn how to use the CLI if you want to do it based on CLI. And so I showed Worker, but I didn't really talk about Worker. I demonstrated doing a CF push. What I could have done instead, because I have Worker watching GitHub, is just do a Git push Worker will grab my Git repo. It will push it will do a worker build and test. If that succeeds, it will push to staging. If staging succeeds, it will send me an email saying it's ready to push to prod if you want. I've never looked at CF at all. In fact, I can log into Worker and say push to prod, and I've never acknowledged that CF exists. In fact, I have Worker wired up just to demo it that pushes both to CF and Heroku off the same code base and runs them in parallel. And that one is to emphasize the point that if you start using CF, you will never code to CF. The biggest mistake we did with OpenStack was get everyone thinking about the APIs and be like, write code to the OpenStack APIs. That's actually as evil as writing code to the AWS APIs. You should be writing code that is an application. And in the case of the Cloud Foundry world, we think it should be 12-factor, right? Which is fairly prescriptive, saying configuration should be in the environment. You should be able to scale horizontally. Don't keep state in process. There's a bunch of guidelines. If you write a 12-factor app, it will work in Cloud Foundry. The one file you may or may not even have is a manifest YAML file. It says, what do you want to name the app? How many instances do you want? How much RAM should they use up? What build pack? That's it. On the services side, the DevOps side of that team, if you're managing data services, again, day one is easy. I created a database. I made some tables. I pointed my app at it. Day two is snapshots, backup, recovery from snapshots, operational concerns around performance, slow query tuning, etc. Those are somewhat different in a CF world than they would be in a Chef on bare metal world or Chef on VM world. Not radically different. And they coexist pretty well. So we have a lot of folks using CF and using Chef in the same data center and having data services managed with Chef environments and then use the data services into CF. Just really, your operational experience is very decoupled from your developer experience, and that's kind of the hacking Conway that we're trying to get to.
So to that, like the workflow you showed here, it looks to me like my Git type of workflow. I run some commands on the command line, my stuff goes in and stuff. Like as a developer, that's hot. I want that. But then as an operations person, like how do I know that this is a radical change to what I'm doing on VMware or whatever? Mm-hmm. There's two interesting projects as part of this, like Logarithm and Health Manager. Can I see like how would I know about that?
So the ops view I don't have on Pivotal Web Services because I'm not part of the Pivotal Web Services ops team, and I just in that I didn't prep properly for the demo, I can't show you Ops Manager. But there is a web console, and for folks that are used to vSphere, whatever that log tool is the vSphere guys use, Operations Manager or something, that's where Logarithm goes to if you want, right? So you can still use, from an operational perspective, still use the same logs tool. If you're used to Splunk, use Splunk as the endpoint of those logs. So the nice thing about the way logs work in CF is it's not an either or. You can put as many syncs onto the log stream as you want. So you can dump it all into Splunk for operational control, and then your apps folks can still do a CF logs. Or if your apps team wants to, they can take a stream of those logs just about their one app and put it into Elasticsearch, Logstash, or whatever, and have their own view, the DevOps view of like, these are the logs I care about, just that app. What's weirdest, I think, and this is probably that line where, I'm trying to be generic about Cloud Foundry as an open source thing and not talk about Pivotal Cloud Foundry, but a lot of the enterprise features of Pivotal Cloud Foundry are on those operator dashboard experience. Here's how you install and scale services using a GUI instead of the Bosch CLI, Bosch YAML file experience, which is the underlying open source. I mean, that's a fairly typical split in enterprise software, right? The core is free, the GUIs you pay for. I don't know. It seems like a business model people are kind of happy with, or at least not terribly unhappy. And of course, I know I demoed like Go and Python. One more question. Okay. For those of you who write Spring, obviously we own Spring and Pivotal as well, right? So STS has great plugins for Cloud Foundry, so you can deploy directly from Eclipse to CF without ever hitting a command line and update and so on. Ditto for IntelliJ, I believe there's plugins there. So there is a large ecosystem of folks who your favorite IDE probably has tools. This is way too small for you to see, but I was pushing recently those same Java apps out to CF. Okay, last question? Anyone in the back? Oh, there's one here, okay.
You spoke a little bit about the culture going from a thing that does all of the things to doing one thing. Is your ideal situation one in which you're somewhere in the middle, or do you like the more focused structure?
That oscillation, I mean, if you think about device convergence, right, we used to have like a PDA and a GPS and a calendar and a phone and all these things. Now we just have smartphones, right? And that's cool. When you get the form factor right, it works. So I ranted earlier this morning about containers and why using containers without VMs around them is like unsafe sex with the internet. I don't want to go into the details, but eventually containers will mature, and using containers without VMs will be fine, right? Not really there yet. It's sort of, I feel the same way about storage. Like there was probably a decade where SANS and NAS was the right answer to storage, and now we have scale-out distributed storage software where having dedicated racks of very expensive custom hardware is not necessarily the simplest, best way to do things. So there's this pendulum that goes software to hardware, GPUs and programming to CUDA versus we'll just write standard code and figure it out. It's always going to oscillate. I think the sort of planning for the future, planning for your own career, or planning for your application is to guess where you are in the life cycle and go, it looks like we've got 5 years going up on this trend. That 5 years is a good plan for an app. Anyone who's planning more than 5 years out is super delusional. Does that answer your question, sort of? Okay.
Yeah.
I really appreciate everybody's time. I know I have run over a little bit, but I hope this was interesting. I will stick around, take a couple more questions before I run off if anyone has closing remarks. And otherwise, run.pivotal.io, go sign up for a free account, kick some tires. And I'm pretty easy to find on the Twitters if you have commentary. You've already got me on Twitter. Cool. Thanks.